Hi all, welcome to new class. Today's class is about mechanical design of overhead lines. So what is overhead lines? Overhead lines are used for the power transmission over long distances. That is, with the growth in power demand and consequent rise in voltage levels, power transmission by overhead lines has assumed considerable importance. An overhead line is subjected to certain weather conditions and other external interferences, and we have to use proper mechanical factors of safety in order to ensure the continuity of operation in the line. So, an overhead line may be used to transmit or distribute electrical power, and the successful operation of an overhead line depends upon the mechanical design of the line. And the main components of an overhead line are conductors, supports, insulators, cross arms, and miscellaneous items. So, conductors carry the electrical power from the sending end station to the receiving end station. Then, supports maybe poles or towers and keep the conductors at a suitable level above the ground. The insulators. Insulators are attached to the supports and insulate the conductors from the ground. Then cross arms, which provide the support to insulators. Then miscellaneous items like face plates, danger plates, then lightning arresters, then anti-clamping wires, etc. So these are the main components of an overhead line. The continuity of operation in the overhead line depends upon the judicious choice of these components. So let us discuss these components in detail. First one is conductor materials. The conductor is one of the important items as most of the capital outlay is invested for it. Therefore, proper choice of material and size of the conductor is of considerable importance. The conductor material used for transmission and distribution of electrical power should have these properties. First one is high electrical conductivity. Second one is high tensile strength in order to withstand the mechanical stresses. Then third one, low cost so that it can be used for long distances. Then fourth one is low specific gravity so that the weight per unit volume is small. And these requirements are not found in a single material. Therefore, while selecting a conductor material for a particular case, a compromise is made between the cost and the required electrical and mechanical properties. The commonly used conductor materials are copper, aluminum, steel cord aluminum, galvanized steel, and cadmium copper. And the choice of a particular material will depend upon the cost, required electrical and mechanical properties, and the local conditions. So, copper is an ideal material for overhead lines owing to its high electrical conductivity and greater tensile strength. And it is always used in the hard drawn form as stranded conductors. Also, the copper has high current density, but copper has higher cost. Then second one is aluminum. Aluminum is cheap and light as compared to copper, but it has much smaller conductivity and tensile strength. Next is steel cord aluminum. Due to low tensile strength, aluminum conductors produce greater sag. This prohibits their use for larger spans and makes them unsuitable for long distance transmission. So in order to increase the tensile strength, aluminum conductor is reinforced with the core of galvanized steel wires, and the composite conductor thus obtained is known as steel cored aluminum, also called ACSR, that is aluminum conductor steel reinforced, and it consists of central core of galvanized steel wires, then surrounded by a number of aluminum strands. So central it is steel. So this is aluminum. So steel cored aluminum conductor consists of central core of galvanized steel wires surrounded by a number of aluminum strands. Then next is galvanized steel. Steel has very high tensile strength. Therefore, galvanized steel conductors can be used for extremely long spans or for short line sections exposed to abnormally high stresses due to climatic conditions. And they have been found very suitable in rural areas. Then cadmium copper. The conductor material now being employed in certain cases is copper alloyed with cadmium. An addition of 1% or 2% cadmium to copper increases the tensile strength about 50% and the conductivity is only reduced by 15% below that of pure copper. Therefore, the cadmium copper conductor can be useful for exceptionally long spans. Next is line supports. The supporting structures for overhead line conductors are various types of poles and towers called line supports. And the line support should have these properties, that is high mechanical strength to withstand the weight of conductors and wind loads, etc. Then light in weight without the loss of mechanical strength. Then cheap in cost and economical to maintain. Then longer life. Then easy accessibility of conductors for maintenance. The line supports used for transmission and distribution of electrical power are of various types including wooden poles, steel poles, RCC poles and lattice steel towers. The choice of supporting structure for a particular case depends upon the line span, then cross-sectional area, line voltage, then cost and local conditions. So first one is wooden poles. These are made of seasoned wood and are suitable for lines of moderate cross-sectional area and of relatively shorter spans, say up to 50 meters. And such supports are cheap, easily available, then provide insulating properties and therefore are widely used for distribution purposes in rural areas as an economical proposition. And the wooden poles generally tend to rot below the ground level, causing foundation failure. In order to prevent this, the portion of the pole below the ground level is impregnated with preservative compounds like creosote oil. Then double pole structures of A or H type are often used to obtain higher transverse strength that could be economically provided by means of single poles. And the main disadvantages of these wooden poles are tendency to rot below the ground level, then comparatively smaller life, that is about 20 to 25 years, then cannot used for the voltages higher than 20 kV, then less mechanical strength and require periodic inspection. So that is about the wooden poles. Next is steel poles. The steel poles are often used as a substitute for wooden poles. and they possess greater mechanical strength, longer life, and permit longer spans to be used. And such poles are generally used for distribution purposes in the cities. And this type of supports need to be galvanized or painted in order to prolong its life. And these are of three types: rail poles, then tubular poles, and rolled steel joints. So that is about the steel poles. Next is RCC poles. The reinforced concrete poles have become very popular as line supports in recent years. They have greater mechanical strength, longer life, and permit longer spans than steel poles. Moreover, they give good outlook, require little maintenance, and have good insulating properties. And this is RCC poles for single and double circuit. The holes in the poles facilitate the climbing of poles and at the same time reduce the weight of line supports. And the main difficulty with the use of these poles is the high cost of transport owing to their heavy weight. Therefore, such poles are often manufactured at the site in order to avoid heavy cost of transportation. Next is steel towers. In practice, the wooden, steel and reinforced concrete poles are used for distribution purposes at low voltages, that is up to 11 kV. So, for long distance transmission at high voltage, the steel towers are invariably employed. And the steel towers have greater mechanical strength, then longer life, can withstand more severe climatic conditions and permit the use of longer spans. The tower footings are usually grounded by driving rods into the earth, and this minimizes the lightning troubles as each tower acts as a lightning conductor. And this is a single circuit tower. However, at a moderate additional cost, double circuit tower can be provided. And the double circuit has the advantage that it ensures the continuity of supply. In case there is breakdown of one circuit, the continuity of supply can be maintained by other circuit. So that is about the line supports. Next is insulators. The overhead line conductors should be supported on the poles or towers in such a way that the currents from conductors do not flow to earth through supports. That is, line conductors must be properly insulated from supports. And this is achieved by securing line conductors to supports with the help of insulators. And the insulators provide necessary insulation between the line conductors and supports and thus prevent the leakage current from conductors to earth. And the insulators should have these properties, that is, high mechanical strength in order to withstand the conductor load, wind load, etc. Then high electrical resistance of insulator material in order to avoid the leakage currents to earth. Then high relative permittivity of insulator material in order that dielectric strength is high. Then the insulator material should be non-porous, free from impurities and cracks. Otherwise, the permittivity will be lowered. Then high ratio of puncture strength to flash over. Then the most commonly used material for insulators of overhead line is porcelain. But glass, then stetite and special composition materials are also used to a limited extent. There are several types of insulators, but the most commonly used insulators are pin type, suspension type, then strain insulators and shackle insulators. First one is pin type insulators. So this is the part section of a pin type insulator. So as the name suggests, the pin type insulator is secured to the cross arm on the pole. Then there is a groove on the upper end of the insulator for housing the conductor. The conductor passes through this groove and is bound by the annealed wire of the same material as the conductor. Then pin type insulators are used for transmission and distribution of electrical power at voltages up to 33 kV. So beyond the operating voltage of 33 kV, the pin type insulators become too bulky and hence uneconomical. Next is suspension type insulator. The cost of pin type insulator increases rapidly as the working voltage is increased. Therefore, this type of insulator is not economical beyond 33 kV. So, for high voltages, that is greater than 33 kV, it is a usual practice to use the suspension type insulators. So it consists of a number of porcelain discs connected in series by metal links in the form of a string. The conductor is suspended at the bottom end of this string, while the other end of the string is secured to the cross arm of the tower. Then each unit or disc is designed for low voltage, that is about 11 kV. So the number of discs in series would obviously depend upon the working voltage. For instance, if the working voltage is 66 kV, then 6 discs in series will be provided on the string. Next is strain insulators. When there is a dead end of the line or there is corner or sharp curve, the line is subjected to greater tension. So, in order to relieve the line of excessive tension, strain insulators are used. That is for low voltage lines, that is less than 11 kV. Shackle insulators are used as strain insulators. However, for high voltage transmission lines, strain insulator consists of an assembly of suspension insulators like this. And the disc of strain insulators are used in the vertical plane. Or we can say the strain insulators are used horizontally. And when the tension in the lines is exceedingly high, as at long river spans, two or more strings are used in parallel. Next is shackle insulators. So in early days, the shackle insulators were used as strain insulators, but nowadays they are frequently used for low voltage distribution lines. Such insulators can be used either in horizontal position or in a vertical position, and they can be directly fixed to the pole with a bolt or to the cross arm. So here the shackle insulator is fixed to the pole. The conductor in the groove is fixed with a soft binding wire, and this is suitable up to 11 kV. So next is cross arms. So cross arms provide the support to the insulators. Then face plate. So what is face plate? So these are used to provide proper indications about the phase or signals of the electricity. That is, it separate and insulate different phases of power in electrical distribution system. Then what is danger plate? So danger plate are signage used for installing on low tension and high tension poles and substations for restricted movement in the high voltage electrical areas. Then what is lightning arrestor? So lightning arrestor is used to protect the insulation and conductors of the system from the damaging effects of lightning. Then what is anti-climbing wires? Anti-climbing wires are physical barriers installed on utility poles or structures supporting overhead power lines. These wires are typically sharp, spiked, or barbed and are positioned around the base of poles or along the structure to deter an unauthorized persons or animals from climbing the, and this is a safety measure designed to prevent accident or theft and to ensure the safety of both the public and the integrity of the electrical system. These are the main components of overhead lines. Thank you for watching the class. If you like the classes, please like, share and subscribe my channel.